All right, good afternoon. Sorry about the delay. Any questions before I start? Yes?
So, for the solution to the homework, I found a very nice, tiny solution on Stack Overflow. It's a one-liner.
Uh-huh.
And maybe I cast it in the beginning a little differently, but other than that, that one-liner, I feel like it's going to be very, very popularly used. What's the policy on cheating and using that?
All right, that's a great segue into what I want to talk about in a minute. Any other questions? I'll get to your question. Any other questions? Yes?
So we're supposed to do quiz before class?
What's that?
We're supposed to do quiz before class?
Yes.
Okay.
Yes, so the quizzes are always before class, noon before class. So on this introductory thing that everyone should take the time to read through, it says quizzes are due Monday and Wednesday, 11:59 a.m. Maybe I should put a minute before noon or so to make that totally clear. So the whole idea of the quizzes is that first of all you do the reading that you're supposed to do before class, and those are these things that are in parentheses behind the lecture. So these are the pre-class reading assignments. So for today it was 10.1 to 10.2 and worked example 10.1. So that's what the quiz is about. On Mondays, the quiz also contains what?
Lab question.
Questions about the lab. Yes. So that way, I'll double check that you've worked through the lab, that you've understood the lab. So on Mondays, you also need to be prepared for those lab questions. So the idea is that I want to make sure that you do the pre-class reading before you go to class, which is why it's called pre-class reading. So every Monday and Wednesday by noon you should have done this quiz. There's no law that says you can't do it earlier. You can do it as early as you like. Other questions? Yes? Where is worked example 10.1? All right. So when you go to the book site, there is, you go browse by chapter 10, worked examples, and there it is. Here, it's a zip file. It contains them all, I think. So you probably have to only do one download. So the bizarre thing is that the publisher, even though they charge a good amount of money for this book, feel that it's too expensive to print out everything, and so they put some of these things on the web. I argue with them every time about this, and I lose every time. So that's where you find the work examples. Questions such as this one are always good questions for Piazza, and I'm almost certain someone did ask on Piazza. Let's just give that a quick try. So, over here there's a search thing. And so but I don't find one where it says where the heck are they. Oh well. Okay, I can't find it. So in a case like that, when you can't obviously find it, then just put a new question on Piazza, and that way you know and everyone else knows. Yes?
So in the lab, you have a little cross next to some profession.
The crown means that you are a king or queen if you solve that question. Those are optional questions. I don't know where the crown comes from. So those are optional questions, and that means you don't ever have to do them. The reason they are there is that some of you are much faster than others. And so we want to make sure that since you're paying for, an hour and a half of lab, more than that, right? How long is the lab?
2 hours 45.
2 hours, my goodness, yes. So for 2 hours and 45 minutes of lab, that those of you who are faster than the others have something useful to do. So if you're not that fast, you don't have to worry about it. You don't have to ever do the crowns. The things that don't have the crown, those are the ones that I expect everyone to do. So if you're very slow in the lab, you should make it up on your own. And I certainly reserve the right to ask questions about them in quizzes and exams. Yes?
So the lab report is due midnight the day of the lab? Or
There is some ambiguity in it. It appears that the Tuesday instructor says that you just luck out and you have a few extra days. The disadvantage of the Tuesday lab is once in a while you're not quite prepared for it, and so to make up for that, he said, just everyone has the same deadline. It's simpler that way. So for the 20-some members of the Tuesday lab, you've just won the jackpot, or a very small jackpot. Other questions? Yes?
Do we have to finish the lab, or do we just turn in what we...
You need to turn in what you have when you leave the lab. You have the option of finishing more and turning it in later. And when would you do that? If you feel that your report was quite weak, you should do that. If you feel that you've worked hard and your lab assistant knows that you worked hard, then you can work on it on your own time without turning it in. So the lab instructor basically gives you 2 points if you did a good job, whether or not you got done. But if he or she thinks you worked hard, you were engaged, you did what you worked at your level. If it looks very skimpy, then that might be just 1 point. And if you didn't show up, or if you just turned in 3 words or something and you basically didn't go with the flow, then that would be 0 points. So the only reason why you would want to turn in a revised report is still working? Yeah, sorry about that. So is that if you feel that you were at the borderline of those 1 to 2 points. So by all means, do the labs, finish them, and except for the crown problems. But I don't want you to spend infinite hours writing these reports. The reports are there just to show, to leave some trace that you've done this. All right, then let me get started with the slides. So, unfortunately, already in homework 1, there was some issue with plagiarism, and so I have to go through this stuff here. So, whatever you turn in, whether it's as homework or as exam work, it has to be your own intellectual creation. You, with your own brain and your own fingers, need to have put it in. And so a good question is, can you copy and paste? It's always okay to copy. The problem is pasting. Copy what you like, but you can't paste. Every time that you hit Control V or you select Edit Paste from the menu, hit Undo right afterwards. You can't do it. If someone explains to you a nifty way of solving a problem, that's just fine. Then use your own fingers to type it up. That's how you learn it for sure. You don't learn anything by pasting someone else's code. So, type things with your own fingers and develop them with your own brain. It's okay that you chat with someone about it and say, I'm having trouble with this, explain the problem. If you feel that the explanation requires the other person to see code, you must do that through Piazza. So if you're talking to someone else and that other person says, let me have a look at your code, and you say, well, let me just email it to you, that's going to set yourself up for trouble, and you'll see in a minute why. Instead say, let me put the code on Piazza. Or invite the other person to put their code in Piazza, and then you can put your improved version on there, as long, of course, as you don't put a working solution on Piazza. That's also not allowed. So if you have broken code, you can put it on Piazza. You cannot put it in an email. You cannot put it on Stack Overflow. You cannot put it in a discussion group. Okay? So what if you use code like the gentleman in the back said? Now he saw this really nifty way of doing something from Stack Overflow, and he felt he really wanted to do the solution the exact same way. Now, I appreciate that that makes sense. And in a situation like that, it's a bit of a judgment call. There's certainly no harm in asking me or asking on Piazza. But my feeling is in that case, you could paste it in, and then you say, taken from, and then you just paste in the Stack Overflow URL. That way, it's very clear that what you're taking credit of is that you have found this super nifty solution that is niftier than what normally people would do. And that seems perfectly appropriate in this case. It's not going to happen very commonly because the homework assignments tend to be fairly specific, but for that homework one, whatever it was, where just about everyone else wrote a bunch of loops, I think that would be an educational experience for everyone. And you could even put that on Piazza. Yes?
So yeah, I like, and that's cool that I can just put the URL. If I wasn't allowed to do that, what I would have done is just broken it up into different assignments.
Right. But yeah, so I don't want people to do unnatural acts. So if there is an elegant way of doing it, I want you to do it the elegant way. But if you saw that elegant way on Stack Overflow, and then you can put the URL and say that's where I had it from. There's nothing wrong with that. Use your professional judgment on it. Generally, if you copy and paste something from just about any source, you can't go wrong by giving the source. If you copy it from Piazza, just put the Piazza URL in there and say that's where I took it from. I mean, it doesn't cost you anything, and that way there's no dispute. Right? Then that way I can say, okay, the code was on Piazza, you took it from there, you modified it, and that seems like a reasonable thing to have done. What you can't do is if someone else emails you the code privately, you can under no circumstances use that code in the form that it is. And I will show you what happens when you try. So here is a result from the plagiarism checker. Let me blow this up. So this is a program called Moss that will go through all of your 160 some submissions, and it'll tell me which ones look very similar to each other. So it found these ones here. And if you just eyeball them, you can see simply by the way that it's indented, the way that the spacing is, these are the same files. There was no retyping going on. There was no rethinking going on. And so these two folks got an email from me explaining what's going to be happening in that case. So this, you simply cannot do it. And so in this particular situation, I have no idea who was the one who emailed what to whom. And so now I'm going to have to let you know a little known fact. I am not Sherlock Holmes. So I'm not even going to try to find out who emailed what to whom. The protocol works. I send everyone an email, say come to my office, and you explain to me what happened. And I have no choice at this point. I have to file a report with Academic Honesty. In that report, I can make various recommendations. And the recommendation that I always make is if this seems to be something that seemed to be a first-time thing, and I hadn't talked about it before in class, then I will report it and recommend no further action being taken. If I get anyone twice in this, I will send a report that says that I would like to give the student an automatic F in the course. So you don't want to do that. These things stay with Academic Honesty, and if the same thing happens in another class or two, at some point they might invite you in to have a conversation about that. I am told that the worst part of this is not the conversation, but the waiting for many hours in the dark antechambers with other students. So you don't want to do that. But I am told it is an unforgettable memory. Yes?
So if you're using something off Piazza, if you're using snippets, how do you want to set it?
If you use it off Piazza?
Yeah.
Oh yeah, just the Piazza URL. The Piazza and the number that they have. Yeah, that would be the perfect way of doing it. So if you're inspired by something in Piazza, simply say you got that from Piazza. I encourage you to use with Piazza, and I see nothing wrong with it. That's again why I say whatever you post on Piazza better be wrong, right? So that whoever uses it has to do some work to fix it. Because otherwise, obviously that would not be fair. It is So I have no problem with you discussing code and, looking over each other's shoulders and pointing out and say, this loop can't be right or some such thing. But you can't send someone code and say, here, look at my solution. That's what undoubtedly happened with I had 4 pairs of this kind of stuff before I got tired of looking. And what happened in every case is one of them apparently sent it to the other person, and it doesn't matter who sends it. You can't send it, you can't use it if someone did send it to you. So what if you find something on a third-party site? If you're in doubt, ask me. I mean, I'm sure there are GitHub sites out there with every solution of every textbook ever, and not all the problems that I give are straight out of the textbook, but some of them are. And in that case, you should probably not use it, because the risk is, again, you're not the only one who found it. And what's going to happen if the other person also found it and turns in the very same solution? Even though I may not be aware of that other solution out there, I will find 2 identical solutions. At that point, I have no choice but to report it. So don't do any of that stuff, and we'll all be happier people. I'd also like to say that I'm giving out the solutions to all homework assignments the Monday, or the Sunday after they're due. Oh, you had a question? Yes.
Sorry, I kind of misunderstood the last thing you said. So if I now Stack Overflow, little nifty thing, and copy and paste it with Mac.
All right, I'm making a distinction between Stack Overflow and one of those sites that I'm sure some of you have run into that has like solutions of all Horstman problems, or they're actually services where for surprisingly little money you can subscribe to really bad solutions done by third world contractors for textbooks from just every author out there. And so I'm saying to use one of those solutions. I mean, you can't very well say, well, I took this from Joe's homework solution service. Right, that clearly would not be a reasonable attribution. Stack Overflow, I feel, is okay because that's a site that's there for sharing knowledge. So if you have a similar site, that's like Stack Overflow, but Stack Overflow has kind of absorbed all the others pretty much, then that's fine, as long as it's a legitimate site. If it's a site that's definitely there for students to swap solutions, no one would cite it in their right mind because that would clearly be unethical. But then what could happen is that 2 different people send me the same code, so they might not have sent it to each other, but it still shows up as the same code. So if you're at all unclear, if you say, I've seen this nifty code, I would like to use it, send me a private email. I'm perfectly fine with answering those and telling you what I would think. So I realize that with everything else, it sometimes is a judgment call. And if you're not sure that you're making the right call, send me an email. Now, most cheating does not get done because people are unsure about this. Most cheating gets done at 11 p.m. when people feel that they have no other option. But you always have the option not to turn in that part of the assignment, and it's generally a better option than being found out. All right. I meant to say something else, but now I can't remember. All right, so back to the course. So interfaces. So presumably you've seen interfaces in CS46A a little bit, and everyone who sees interfaces the first time, not everyone, but many people who see interfaces the first time find them at the beginning somewhat pointless. They say, what's the point of an interface? You have a bunch of methods, and they do nothing. We're not even providing an implementation. And then we're having a class, and then the class implements them in some way. So, it doesn't seem like a worthwhile thing. It seems like a bunch of bookkeeping at first. And so, the point of using interfaces is subtle, and it is not really here for the cat. The cat by itself has no great benefit. The interface by itself looks like it has no value. The value lies in what you can do with these interfaces. So over here I'm writing a method called serve, and serve now gets to have a parameter of type customer. So the beneficiary is the author of serve, because that author now only needs to write a single serve method, as opposed to one serve method for cats and another serve method for person objects. So that's where the benefit lies once you want to write these methods. Now you might say, I never wanted to write one of those very general methods in my life. And that is true, but that'll at some point change. There was a question? No? Okay. So, okay, I'm going to skip past this one because we're running a little late. But I do want to do this one. So let's do clicker question 2. And now, okay, here it goes. So this is the picture. That's the chapter opener. And so there's a caption that mumbles something about that this thing should explain to you what interfaces are all about. And so I want to see how this picture is working. So if we'll go back to the previous slide, there's a service. In this case, it's literally the service in the restaurant. And so this restaurant serves anyone who conforms to the customer interface. Cats do, as long as they're willing to eat, as long as they can eat and pay. And people do, if they can eat and pay. And anyone who can eat and pay is going to be served by this restaurant. So the key is that conforming to this interface means serve will do its job, namely to serve and collect the payment, or otherwise let them do the dishes. So in this picture here, so it says something about the interface for plugging in attachments. So the interface, I guess, would be like that thing up here where you plug in the attachment. What would be the objects that conform to the interface? I don't know if you're familiar with these mixers, right? I mean, you can put in a beater thing or a dough mixer thing or whatever. And so any one of those has the same kind of thingy on top that fits in. And so those would be the various objects so that of the conforming classes. So let's see how we're doing here. Okay, can we hurry this up a little bit? We should be able to get this up to at least 135. Hey, come on, guys. All right. Okay, so yeah, I was afraid of that. So the service that the mixer provides to any object that's willing to conform to the interface, namely to that plug that's there on the top of the mixer, the service is rotation. The only thing that a mixer does is it rotates. If you manage to put an attachment on your laptop that fits onto, where you plug it into the mixer, and then you turn on the mixer, what's the mixer going to do? It's going to rotate your laptop, right? Really fast. Does it make any sense? Not necessarily, but that's what the mixer does. That's what a mixer does. It does one thing in life. It rotates. Whatever you plug it in, it rotates it. The mixer has no idea whether you plugged in one of those whiskey things for mayonnaise or a hook to beat dough. Whatever you plug in, the mixer rotates. So that's the service, and it's an abstract thing, right? A mixer does something that it says, I have no idea what it is that I'm rotating, but I'm going to rotate it. That's my mission. And so the interface, in this case, is that minimum thing that one needs to be able to have in order to work with the mixer. And that is, a little piece of metal with a little ball thing in there that you can plug in. If your laptop has that, maybe you can make one that plugs into the USB port. Then it'll mix, right? It'll rotate it. So the mixer has no idea whether ingredients are involved. So, you could be putting in here, I don't know, a bell or something, and it would rotate it and it would ring the bell. So ingredients don't have to be involved. It has no idea that, there's liquids or mayonnaise or so. So the only thing that the mixer knows about is I'm going to rotate whatever plugs in. And so that abstraction is a good thing to keep in mind. So now I came up with this measurable interface, and which, again, when you see it the first time, it looks like a really pointless thing. It's not a standard interface. It's been designed to be like the simplest possible interface that someone can think of to get the mechanics across. And we'll see in a little bit, in the next lecture, when we look at the comparable interface, which is more standard, we'll see what difficulties one runs into with a seemingly simple interface like that. So, so measurable is something that can be measured. And again, it seems utterly pointless, but the point is that one can now write useful functions. So here's average, for example. Average is willing to, in this case, not rotate, but compute the average of any measurable things. And so let's see how it does it. It has no idea what it is that you're going to be averaging. The weights of people, the sizes of countries, the balances of bank accounts, it doesn't know. All it knows is I'm getting a bunch of objects. Each of them is a measurable. And so on each of them I can call the getMeasure method. How does it know that it can call the getMeasure method? That's really the only thing it knows about measurable, right? Because it's in the interface. So the reason that you have to write down the interface is so that this piece of code compiles. So if you were to put in just object here, it wouldn't work because object doesn't have a getMeasure method. So the only point of the interface is so that this kind of services can be programmed and compiled. All right, so how can you then use this thing? You've seen that in the book. There's these tedious examples where they give you a piece of code that now measures the average balance of a bank accounts. That measures the average area of a bunch of countries, and each of them implements this interface in the trivial way by having getMeasure return, either the balance or the area. So another way of looking at this, and I rather like this picture, is in terms of what's called coupling. So when you have an arrow from one class to another, like this one here, the started arrow, that's a coupling arrow. That means bank account knows about measurable. Where have you seen these arrows before? In BlueJ, right? BlueJ shows you both the inheritance arrows and it shows you these coupling arrows. And so this means that bank account knows something about measurable. Is that a good thing? There was a section in chapter 8 in CS46A that said something, I think. Maybe it's in chapter 12, which we're skipping, unfortunately. So the rule is that you can't avoid coupling, but coupling is generally bad. So you don't want to have a situation where everything depends on everything. That makes your code hard to maintain. When any one part of it changes, then all the other pieces might change. So the less coupling, the better. Code that doesn't know about some other code can't break when that other code changes. So in this case here, what the advantage that we're having is that the data class here, that's the one with the average method, the data class knows nothing about bank accounts. You notice there's no arrow. It knows nothing about countries, and that's good. So in the world of object-oriented design, not knowing is good. The data class only knows about one class, namely about measurable. So that's the advantage of from a design perspective of using interfaces, that it decouples on the one hand the service, so this here is the service part, and these are the ones that are the beneficiaries of the service. And the only overlap is the actual interface. So that's what we want to achieve. All right. Now we have a new and more interesting interactivity where I want you to actually start up Eclipse and do something. So go ahead, start up Eclipse. And it's going to take us 5 minutes or so. Oh, I have to do it the other way. So my hope is that everyone has already downloaded this book code, but if you haven't, you can certainly do it right now. And when you do it, make yourself a directory book. I think that's one you have to make. Yes. Make yourself a subdirectory book and put it inside there so that you have these chapters in here. So we want to make a project okay, what's the next step? So I said file new project, and now what is the what is the next step? Thank you. You uncheck this evil button, and then you can browse for the location. And what was section 1, right? Yeah. And now notice that it put in a project name. Unfortunately, not a very good project name because it didn't use this directory, but it's easy enough to fix it up. Okay, now we're finished. All right, so here's our project. Here's the default package where all the code is. So into here, we're now supposed to put in, this word class. So new class word. Save that. So now it says somewhere we're supposed to be putting this. Oh, I need to actually open up the clicker question. Let me do that while you guys work on this. Clone poll. Clicker. So there's a whole bunch of classes here. There's the bank account that by now should be familiar, the country class, the data class. That's the one that has the service, the averaging service. That's the service we want to use, right over here. Then there's measurable. There's the tester. There's the word class. So in one of these classes, you're supposed to put in this statement. Yes?
I thought you said put in the tester.
Yes, so I would agree with you there. So we're going to put in the tester. And so we're going to put it at the end. And now, you know this from CodeCheck that there's different ways in CodeCheck on how I can test your solutions. There's one scheme where it just feeds in something from standard input, and there's another one where it calls a method, and then there's one where it runs your program, and then it analyzes whether your program prints what's expected of it. And so that's the same program as here. Notice that in this program, there is always a pair of lines with some label and then the expected label. And then there's another one with some label and the expected label. Now over here, we have no label, which is fine. You don't have to have it. And so over here, then we want to print system And so my question is, what's expected? What do you think it should print? So that's the question that you should answer in Piazza. And 29 people have done so. So if the other 100 or so would do the same. And then just run it and see if it did what you expect. So if you're still pondering on this, you could ask yourself, how does it measure the word hello? And the word class will tell you how it measures it. So what's the measure of hello? Then over here, sorry, with the tester, what's the measure of world? And what's the average between the two? Presumably that's what you expect. All right, so most people chose. Okay, so most people chose 5.5. So let me follow that. And so, sure enough, it says 5.5 and expected 5.5. What would have happened if you would have simply left this blank and ran the program? Yeah?
You would have just put it out expected, colon.
Exactly. It would have, and of course then you could have said, oh, now I know what to expect. And you can fill it in, but that's not really satisfactory. The reason it is a really, really good idea to write down what you expect first is it makes you think about the thing that the program is trying to do. So there's a whole school of what's called unit testing that says that programming should be test driven, that when you program something you should always think about how can you test it. How can you, and that exactly means to have an idea of what the expectation is. So these are like little what's called unit tests. Later in one of the labs you're going to be learning the so-called JUnit framework for unit testing, and JUnit is a little bit better than this thing with the expected, but it requires just a bit of setup, just a bit of experience to do it right. And so in CS46A I designed this thing with the expected, what really is just a convention, with the expected convention, so that one can do basic testing without having to do JUnit. And of course, one variant of CodeCheck is that it analyzes the output to make sure that the expected stuff works. All right, so that's that. So every once in a while, I might ask you to write a tester. When I ask you to write a program that ends with TESTER, like in an exam, that may well happen. That means you're supposed to write something that prints an even number of lines where every second line says expected. All right. Next thing that's often confusing to people is interface variables. So over here, I say measurable is an interface. An interface is not a class. Because it's not a class, there can't be objects. You have to have a class in order to have objects. So how come you can have a variable of type measurable? And so it's a type, but it's not a class. In Java, there are other things that are types but not classes, like int. Int is not a class. And measurable is something that you can use to declare a variable. But when you put something in, it has to be an object of some class. So it would be a mistake to say new measurable. That would be trying to make an object of type measurable, and it's not a class, so you can't do that. So measurable is a variable, and you have to instantiate it or initialize it with an object. I should say initialize it. You have to initialize it with an object of a class. This was something that appeared in Lab 1, Let me show you this real quick, because the lab assistant said that many people were super confused by that. Find this just a second. Yeah, this is what I want. Ah, yeah, here. So there was a step where you had to make a variable book of type address book. An address book is an interface. And so the class that implements that interface, well, that's an interface with a hefty number of methods actually, it's called ArrayList address book. And so I said you should make the variable of type address book and not of type ArrayList address book. And this is something that shows up later in the lab. It might have been in an optional part only, that I don't remember. But in general, when you declare a variable, you want to make the variable as general as possible. There may be other kinds of address books. In fact, you'll see one, I believe, in lab 2 or lab 3, I can't remember. There's a mock address book for testing at some point. And so by making it an address book, that way it's you're guaranteed to have it hold any address book that you want. So over here, with the same thing with the measurable, this way it can then hold any measurable that we want. All right, so that's the confusion that people have. Next thing that, yeah.
Yeah, so when you say it's a type, what is that? I know what primitive types are.
Okay, a type is something that specifies what you can do with the values. So something is of type int because you can do modulus on it and multiplication and addition and so on. And double is a type that you can do different operations with. Object is a type, string is a type, these are all types. And measurable is a type. So a type is something that is specified by whatever you can do with it. A class is something much more specific. A class is something that is a subclass of object that has a toString method and a hashcode method and so on. Like a measurable doesn't have any of those.
The object is an object class.
Object is a class.
You said object type.
And it's so every class also gives a type.
I'm so confused.
So, all right, so I'll draw a picture. So if this is all types, there's three kinds of types in Java: classes, interfaces, and primitive. So any one of those is a type. And when you declare a variable, you first do a type, and then you do the name. So the thing that's to the left of a variable declaration is a type. So for example, you can say int name, and that means int must have been a type, otherwise you couldn't have been able to put that. You can say measurable opt, and that means measurable was a type. You can say bank account, and so bank account is a type. Now let's see if I lied. Here I say int bracket a, right, for an array of integers, or an array of int to be precise. Doesn't that mean int bracket is a type? It sure does. Int bracket is a type. But I didn't say anything about arrays in my circle here. Arrays in Java are actually classes. So oddly enough, an array in Java is a class, and you could then say object obj equals A after you've done this. They are classes that we have no, they don't have very much. They don't have a lot of methods. Do they have any methods? Like if I have an array, let me take this off. This is a total aside, but it's useful to know. So what method could I call an A? Okay, length is weird, right? Length is not a method. How do I know it's not a method? Doesn't have the parentheses, right? So it's a weird read-only field that only exists for arrays. Someone said toString. Absolutely. Does anyone know what's going to happen? Yeah, it's going to print the type as bracket I and then the hash code. It inherits that method from object. Any other method? There's hash code, of course. And thus gives you the hash code. Why does this hash code not look at all like this hash code? The second one is in hexadecimal. So if I wanted to see this other one in hexadecimal, I guess I could. And now you can see it's the same, right? 574 CAA 3F. What's hexadecimal? It's just like decimal except you have 16 fingers. Right? So that's why we like to import programmers from Mars, because not only do they have those nifty antennae, they also have 16 fingers, so hexadecimal is simpler for them. Little known fact. So why did I do all of this? Oh yes, just to show that an array is actually an object. It has the same methods that an object has. None of them are very useful, so we don't normally use that. But as a fact, it's a fact that the types in Java are primitive types, class types, and interface types. Now the trick question, is void a type? Not really, because you can't declare a variable by saying void x. Right? So void is weird. You can only use it as a return type. All right, moving on to casts. So a cast is this weird thing where you take something, in this case, something that's of interface type, and then you put in parentheses the type that you want to have around that. So first of all, I should say that casts are pretty rarely used. So you can go through months and months of programming without ever writing a single cast. And so the situation that I'm giving you here for using one is fairly common and fairly typical, so it's worth trying to understand it. So here I'm writing another nifty general method. I'm writing a method that says which of two objects is larger. And that's easy enough to do. I compare the measures. And if the first one has a larger measure, I say obj1 is larger, and otherwise obj2 is larger. So let's see, what do I know about the inputs? I know I want to make it as general as possible, so it's immeasurable. And this one is also immeasurable. And what do I then know about what I produce? All I know about it is it's immeasurable, so I have to put measurable here. I can't put bank account, because maybe I compared countries, or words. And so this is the natural way of writing the larger function for measurables. And now let me try to use it. So I have two countries, and I want to find out what is the larger of these two countries. And so I get it back, and I know it's a country. I put in two countries. It's got to be one of those two, so for sure it's a country. So I want to capture it as a country. And I want to put it as a country, because otherwise it's hard to use. But the compiler will say, no, 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 no. The return type of larger is measurable, A measurable could be anything measurable. You can't move a measurable into a country because maybe you were lying. So fine, I go with the flow and I declare it as a measurable, but now I'm trapped. I cannot do much with this max. For example, I can't call getName because max is just a measurable, and there's no way of knowing whether this particular measurable has a getName method. The only thing that I know about measurables is they have a getMeasure method, but that's all I know. So in this very specific situation where you know more than the compiler, it doesn't often happen that you know more than the compiler, but in this case you do, you can tell the compiler, hey, listen up, I know it's a country. What happens if you lie? Will your keyboard melt into a puddle of plastic? No, right? You get a runtime exception. At that point, yeah, your program will die with an exception. It's called a class cast exception. It says that you're trying to cast to the wrong class. That happens once in a while when people thought they knew, but it's easy enough to fix. You look up in that line, it's usually pretty obvious. So, like I say, these casts are pretty rare. I will not have a million quizzes about casts just because they're pretty rare. But once in a while, you need to be familiar with them on a reading level. All right, we'll have one more code thing here, do we? No. Yes, we do. Yes, and this one I really want to do because it's kind of fun. So this is a worked example. So there's a smallish number of worked examples with the book. They're supposed to add enrichment, extra, more complex problems. And so what always happens is people say, gosh, there should be more examples. And then I say, fine, let's put more examples. That'll be 10 pages per example because it just takes so long to explain a real meaty example. And then the publisher says, hell no. And so now we put them in PDFs. So you download them from the site, like I've just shown you. And it's okay. You just read through them and when I ask you to. So in this particular example, we have a different interface. That interface is called sequence. This is actually an interesting kind of sequence. It's an infinite sequence. So all we know about the sequence is when you call next, you get the next value in the sequence, and that's an integer. So it's some infinite sequence of integers. And any old infinite sequence of integers could work. Like, what's your favorite sequence of integers? The digits of pi, right? My favorite sequence is 0, 0, 0, 0, 0, and it keeps on going like that forever. Any number of sequences that you can imagine, or another favorite sequence is that the next one is the next combination of the lottery that makes you rich next week, forever. So whatever those sequences are, we have these sequences. And now we want to analyze them in some way. So for whatever reason, we might want to analyze what their last digit is. I don't know why, but we do. And so we wanted this to work for any old sequence, and it's an infinite sequence. We can't compute statistics about infinite sequence, so we have as a second parameter how many values we want to draw from that sequence. And now you see here, what's in this method here only requires one method, namely next. Otherwise, we know nothing about the sequence at all. We extract the last digit, we increment a counter, and that's how we process the sequence. It works for any old sequence at all. So this is again one of these reusable services. It's reusable because it works for any sequence, and it doesn't require any knowledge about the sequence except that it has the next method. So here's an example of a sequence, a square sequence that produces squares. Every time that you call next, n gets incremented, and we return the square. So the first call to next returns what? One, right? Because when n is not initialized, it starts out its life at 0. It gets incremented, and then 1. The next call next will set n to 2, and it returns 4. Here's another way of generating a sequence. This is a random sequence that returns random numbers. All right. So when actually, let me run this example really quick so you see. Okay. Come on, restore. Okay, here we go. File, new Java project, browse. Here it is. Ah. So here's this output here, and the first one that you see is the squares, and what you see here is you see the last digits. The second one is those random numbers, and you see they seem to be kind of randomly distributed for the random numbers. So the chance that a random number has a 0, 1 to 9 as its last digit are pretty much the same. There were 1,000 numbers, so they're all pretty much close to 100. And that's what you would expect for a random number. Well, you would expect that their digits are randomly distributed. Now for squares, that is not the case at all. Did you know this? That if you list the first 1,000 squares, that exactly 100 of them end in 0, and that 200 of them end in 1, 4, 6, or 9, and none of the squares end in 2, 3, 7, or 8. Bring it up at dinner and see if the people you have dinner with were aware of this amazing fact, right? And it's not something that normally enters the conversation. But there it is, and it can't be an accident, and in fact it's not an accident. And so what I'm asking you to do is, in the next clicker question, is what about the cubes? Run this program, do exactly what I just said, make that project, then make do whatever you want to do to do it with cubes, and tell me what you get. Okay, go for it while I set up the question. Yes?
Can you explain how the array increments? I'm just not getting it, I'm just not looking how when you have a plus plus you do incrementation like that, how last digit.
Oh, I see. Yes. Let me get the code. No, I've got to do something about these. In the wrong place. Sequence step. Yeah. You're talking about this one.
Right.
Oh, I see. If I were to write, I'm just going to uglify this code for a minute, then fix it again. If I write n++, that's the same thing as saying n equals n plus 1. If I say counters last digit plus plus, that means the same thing as saying counters last digit So I have an array of 10 counters. The counters for the last digit 0, 1 up to 9. So counters has slots from 0, with indexes from 0 to 9. And let's say previously this there were 117 occurrences of the last digit 2. Now I come into here, and now I have another number that ends in 2. So then value mod 10 would be 2. So last digit is 2. And then over here, this would be counters of 2. And that's now set to counters of 2 plus 1. 117 is counters of 2 plus 1 is 18 is put back in here. So, and the reason that we use the plus plus is just because it's shorter. Yes, how do I know it has to be less equal 9? How do I know it's less equal 9? Well, because it comes out of this here. Right, it's something mod 10. Now, actually, there is a danger here, and I don't know if you ran into this danger yet, or you're going to run into it in the homework. So, what he correctly said is that this stuff only works if last digit is less than 9, because otherwise this array index here would be out of bounds. There's another thing that has to be true about last digit. It has to be non-negative, right? Could it be negative? Where does it come from? Well, it depends on this value. Where does this value come from? It comes out of the sequence here. There's nothing that excludes that, right? So the code that's in the book kind of glossed over this entire thing, which is another way of saying it's actually kind of a bug. And so you're going to run into that because the random sequence can produce negative numbers. So you'll have to fix that in the homework. All right, let's see. Never mind the homework here. So what was our job? Oh, to say, what about cubes? Well, we have a square sequence, so we can just copy that and paste it and call it cube sequence, I guess. And then we would return n times n times n. All right, that's the cubes. And we must have a demo program somewhere. Yep. I can just turn the square into cube, right? And then what happens when you run it? Let's see, 105 people have an answer. If we could get another 30 or so to commit themselves to an answer. I mean, all you have to do is do what I just did and run it. Okay, so this was our random ones, and here are the cubes. So the cubes give us every digit with the same probability, and I mean, wow. This is not something that's up to interpretation. How can we have different answers? I'm going to close the poll here. Okay, what were the options? So this is obviously the correct option here. I don't see how could anyone have gotten option 2. Someone who had option 2 explain how they got that? So what you need to do to get this particular kind of questions right is you need to just do it, right? You have Eclipse, you fire it up, you change the code, and with a question like this where it's not something that has to do with judgment or misunderstandings or something, really my hope is that next time there's only one answer. This is something, you know, you ought to be able to get Eclipse to work and do this kind of stuff in reasonable time. If you find that Eclipse is still challenging you and you're just slow in doing this, get faster. You're going to need that speed in the exam because the exam is going to be on your computer with Eclipse doing things in